Okay, so members, welcome. Today we are going to see how do we handle such a proof, but please don't forget to subscribe to the channel. Now, to handle this proof, we are going to use some bit of sine rule. We are also going to use some properties of complementary angles. Complementary angles are angles which add up to 90 degrees. So here, I'm going to handle this in every time. So the sine rule says this, meaning that if C over sine is equal to R, meaning that if I mix the subject, I get 2R sine C from here, the same to be the same to A. If this is equal to this, we make A the subject. The property I'm talking about also is 90 minus A becomes cos of A. Then cos of 90 minus A becomes sine A. If this is 90, this is true. Now, if I start with this, if I consider this, here I have A minus B, A plus B. Where there is A, I put 2R sine A. Then B, 2R sine B. I don't have C, so I don't consider it. Now you see that 2R is common throughout. I divide it by 2R. Then here I'm going to apply factor formula, which says this will be now 2. If I'm subtracting, then this is that. Then cos, then I add the whole over 2. Then down the side, some adding, so this will be you add for sine, then for cos you subtract. So now from here, if you are to rearrange, you see that this 2 will go away, then this and this will give you tan n minus b over 2. Then have to remain with your cos over 2, the whole divided by this remains. Now, I'm seeing that in my proof I have a C. I don't need this. This is already there. I don't need this. How do I remove this? I remember that A, B, and C were angles of a triangle, meaning A plus B plus C is equal to 180. Why? Because all angles of a triangle add up to 180. Now I make A plus B the subject from here. Minus C. So that I'm dividing by 2. So I divide here by 2. So A plus B. Divide here by 2. 90. Divide here by 2. That's what I have. Now I introduce cos here. Be equal to cos and I see over 2, which will be, now we are going to use this property, cos of 90 minus the angle here is the same as sine of that angle. So now this will be, it's going to be now sine of C over 2. Then if I introduce sine here, it's going to be sine of 90, which will be the same property. If you add sine 90 minus something, you're going to get cos of that something, which will be now cos of C over 2. So, putting them back here, we start having tan n minus b over 2. Then cos of this, so that I have sine C over 2. Then the whole over this one is giving me cos C over 2. Now you see this one, sine C over 2, cos over 2. This will be now over 2. Then sine over cos, we get tan C over 2. Now this side I have a minus b over a plus b. Now this is my proof. I want a cot, so I divide this side. This will be 1 over tan, and 1 over tan is cot. So if I divide this here, I have now a over a plus b. If I divide this here, I'll be having now cot of C over 2 minus b over 2. And that's the proof. Why? Because we know 1 over tan C over 2 will give us a cot C over 2. So if you divide this side, that's why I'm having this. So please remember, that's the proof. Please try out these two. I wish you the best.